Hi guys, welcome back to my channel. Let's quickly provide a lasting solution to the problem we have on the board. So I have this sextic equation, which is very interesting and simple as well. S cubed plus 20 upon s cubed plus 2 equal to 7. Now, if we have equation with fraction, the first thing that comes to mind is to multiply each term of the equation by the least common denominator or the lowest common factor, as the case may be. But we shall not do that in this case because that may complicate the solution in the sense that this is an entrance exam. Hence, I shall play some tricks before making algebraic substitution. So first and foremost, I will add 2 to both sides. We're going to be having s cubed plus 2 plus 20 upon s cubed plus 2 equal to 7 plus 2. So we've not altered this equation in any way because we've added 2 to both sides to ensure parity and the equation is still balanced. So 7 plus 2 is going to give us 9. So we shall write s cubed plus 2 plus 20 upon s cubed plus 2 equal to 9. So at this junction, shall then make a substitution. I'll say let y equal to s cubed plus 2. So we shall then rewrite this equation in a more condensed form. So in place of s cubed plus 2 here, I will infuse y. Do the same here. We shall be having 20 upon y, everything equal to 9. Then the next thing we shall do again is to multiply each term by y. So y multiply y will be y squared. Y multiply 20 upon y, that will give us 20, y will cancel out. Y multiply 9, that will give us 9y. So this is a simple problem. So we shall rearrange this equation in a standard form. So that will be y squared minus 9y plus 20 equal to 0. So this is a simple quadratic equation which is easily factorable. More so, the leading coefficient here is 1. So we look at the factors of 20 that can be added to give 9. That should be 4 and 5. And because we have negative 9 here, we shall consider negative 4 and negative 5. Because negative 4 added to negative 5 will give negative 9. Negative 4 multiplied negative 5 will give us positive 20 or 20. So in place of minus 9y, we shall write minus 4y and minus 5y. So that becomes y squared minus 4y minus 5y plus 20 equal to 0. We then factorize by grouping. I'm doing this for the sake of our audience in high school. So in this first pair of group, so the HCF of y squared and 4y is y. So y divided into y squared, we have y. Y divided into 4y, we have 4. And here we factor out negative 5. So we're going to be having y minus 4 equal to 0. Now if I pick the exteriors, we shall be having y minus 5 multiply y minus 4 equal to 0. Now using the zero product property, it implies that y minus 4 equal to 0 or y minus 5 equal to 0. So if we add 4 to both sides here, y equal to 4. If we add 5 to both sides, we have y equal to 5. So 4 and 5 are the values of y that satisfy this quadratics. Then we shall recall that y is equal to s cubed plus 2. This is our substitution. Then we shall then have two cases. And also, we are actually solving for the real values of x in this problem. So I will take up this part of the board. We are at the very last lap. So case 1, case 1. So when y is equal to 4, we shall have s cubed plus 2 equal to 4. So if I subtract 2 from both sides, s cubed will be equal to 2. Then if I take the cube root on both sides, we shall be having cube root of s cubed equal to the cube root of 2. So cube root will annihilate cube. We are going to be left with s equal to the cube root of 2. Then case 2. When y equal to 5, we are going to be having s cubed plus 2 equal to 5. So s cubed will be, if I subtract 2 from both sides, that will give us 3. If we then also take the cube root on both sides, we're going to be having s equal to the cube root of 3. So s equal to the cube root of 2 and s equal to the cube root of 3 are the two values of x that satisfy the real solution to the original equation. So that's it for today. If you enjoyed this video and you like it, please do well to share with your learning friends and colleagues, and make sure you subscribe and turn on the post notification so that you'll be notified anytime we upload a new video. See you next time and stay blessed.